Hello everyone, you're watching the channel Military TV. Today we'll show you why Russia's MiG-31 is a supersonic assassin. The Mikoyan MiG-31 Foxhound is a supersonic interceptor aircraft developed for use by the Soviet Air Forces. The aircraft was designed by the Mikoyan Design Bureau as a replacement for the earlier MiG-25 Foxbat. The MiG-31 is based on and shares design elements with the MiG-25. The MiG-31 has the distinction of being one of the fastest combat jets in the world. It continues to be operated by the Russian Air Force and the Kazakhstan Air Force following the end of the Cold War and the collapse of the Soviet Union in 1991. The Russian Defense Ministry expects the MiG-31 to remain in service until 2030 and beyond. The maiden flight of the MiG-31 took place in September 1975. MiG-31 can work efficiently in all weather conditions while fulfilling visual flight rules, VFR, and instrument flight rules, IFR, day and night. It is equipped with state-of-the-art digital avionics. MiG-31 was the first Soviet fighter aircraft to have true look-down and shoot-down capability. Approximately 500 MiG-31 aircraft have been produced, out of which 370 were delivered to the Russian Air Force and 30 are in service with Kazakhstan Air Force. The remaining aircraft were upgraded to different variants under several upgrade programs. Only some of the Russian MiG fleet have been upgraded to MiG-31BM standards under the upgrade program. The MiG-25 Foxbat was unable to fly at low altitudes. The installation of inefficient turbojets led to decrease in combat range at supersonic speeds, and an increase in the speed gauge of the MiG-25 resulted in the destruction of the aircraft's engine. In an effort to overcome the drawbacks of the MiG-25 Foxbat, the MiG-31 was developed to fly at low altitudes with required supersonic speeds. MiG-31 is equipped with efficient low bypass ratio turbofan engines, which allow an increase in combat range. Production of the MiG-31 began in 1979, and the aircraft was fully operational with the Soviet Anti-Air Defense (PVO) by 1982. The economic slowdown in the USSR has made the maintenance of its complex MiG-31 aircraft difficult for many squadrons. As a result, around 20% of the MiG-31 aircraft were removed from service. About 75% of these aircraft, however, re-entered service with the Russian Air Force in 2006, when strong economic growth returned. The MiG-31 has a highly aerodynamic and streamlined body to enable flying at high speeds at low altitudes. The aircraft is specifically designed to track multiple targets simultaneously at high altitudes. The MiG-31's aircraft contains various materials, including welded nickel steel, 49%, titanium, 16%, aluminum alloy, 33%, and 2% of composites. 4 underwing pylons are also fitted in the fuselage of the aircraft. The aircraft's fuselage is designed to provide lateral rectangular and diagonal cut air intakes and features a bubble canopy with a long pointed nose. The wings are sharpened and swept back with square tips and negative slant. The variants of MiG-31 include MiG-31A, MiG-31B, MiG-31BS, MiG-31E, MiG-31F, MiG-31BM, MiG-31FE, MiG-31LL, MiG-31M, MiG-31D, and MiG-31S. Commercial satellite launch variants MiG-31A and MiG-31S have been used to train astronauts, to conduct research in the upper atmosphere, and for space tourism by launching the Aerospace Rally System rocket-powered suborbital glider. MiG-31E is an advanced version of the MiG-31 supersonic interceptor aircraft. The variant is equipped with RP-31E airborne phased array radar. It can track 10 and destroy 4 targets from long distances. Under normal and adverse weather conditions, the MiG-31E has the capacity to destroy aerial targets flying at 50 meters to 28,000 meter altitude in front and rear hemispheres. In the absence of a ground air defense system, the MiG-31E aircraft scans airspace at a width of 900 kilometers to 1,000 kilometers. An infrared IR seeker unit installed in the variant can track targets by its heat emissions in the passive mode of a blind attack. The MiG-31M is an advanced version of MiG-31. The variant was developed by upgrading the cockpit of MiG-31 with a number of cathode ray tubes, CRT, and an increased number of missiles. MiG-31BM is a high-speed multifunctional long-range fighter jet that can destroy both air and ground targets. The variant is equipped with upgraded avionics, hands-on throttle and stick controls, liquid crystal color multifunction displays, a powerful onboard computer system, digital data links, and a phased array radar. It has the capacity to intercept 24 targets simultaneously. MiG-31D is an anti-satellite missile aircraft developed as part of the U.S. ASAT anti-satellite weapons program in 1987. It is fitted with a single large missile beneath its fuselage and a special upward-looking radar. An associated intercept fire control system is also equipped. The MiG-31 cockpit is equipped with digital avionics, such as MFDs and liquid crystal displays, LCDs, which provide updated instrument readings and radar information. Both front and rear sides of the cockpit are equipped with 0-over-0 ejection seats, which will allow the pilot to fly at the altitude and airspeed preferred. The pilot sits in the front seat of the cockpit, while the Weapons System Officer, WSO, sits in the rear cockpit seat, controlling the radar operations and weapon deployment, thereby decreasing the workload of the pilot and increasing the efficiency. 4 long-range Vimepel R-33E air-to-air missiles are installed in the MiG-31 aircraft. The R-33 can be launched in inertial navigation mode to shoot the target at extreme range. It can be guided in semi-active radar homing mode for initial acquisition and mid-course updates. It is used for attacking large and high-speed targets such as the SR-71 Blackbird, the B-1 Lancer bomber, and the B-52 Stratofortress. The aircraft is also equipped with 4 short-range R-60 Mk missiles and 2 Biznovit R-40TD1 medium-range missiles. A 6-barrel 30mm internal cannon, GHS-623M, is installed above the starboard main landing gear bay of the MiG-31 aircraft. The cannon contains 800 rounds of ammunition and can fire at a rate of over 10,000 rounds a minute. MiG-31BM can accommodate the AA-12 Adder missile and various Russian air-to-ground missiles, AGMs, such as the AS-17 Krypton anti-radiation missile, ARM. The MiG-31 can climb at a rate of 208 meters a second and has a capacity to fly at 3,000 kilometers per hour. The ferry and combat ranges of the aircraft are 3,300 kilometers and 720 kilometers respectively. The maximum takeoff weight of the aircraft is 46,200 kilograms. The cruise range and wing loading capacities are 1,620 meters and 665 kilograms per meter squared, respectively, while the maximum G-load is 5G. The MiG-31 aircraft is equipped with the world's first electronically scanned N007 Zaslon phased array radar. It is also known as SBI-16 Zaslon Flashdance radar and operates from the rear cockpit by WSO. It can receive signals from early warning radar, EWR, and airborne warning and control systems, AWACS. Zaslon has the capacity to scan 200 kilometers distance. The radar can trap 10 targets and engage 4 simultaneously flying in the surrounding radius of the aircraft, behind and below the aircraft. The antenna of Zaslan is fixed and can be moved electronically. The electronic steering of the radar beam is much faster and accurate than mechanical steering. The Zaslan radar has the capacity to search and attack various targets in air and ground using continuous and discontinuous fields of control and guidance commands despite target defensive maneuvers, electronic countermeasures, ECM, and adverse weather conditions. MiG-31 is equipped with light-duty LD/speed and direction SD sensor, track while scan TWS radar, infrared search and track IRST system, and radar warning receiver RWR system. The aircraft assigns partial power to track targets and the remaining to scan. The TWS radar system in the aircraft uses 2 technologies: phased array radars and computer memory devices. The IRST sensor detects and tracks jet aircraft and helicopters that emit infrared rays, while the RWR systems detect radar systems emitting radio waves through the ground or in the air. The RWR comprises of a visual display unit, VDU, in the cockpit that monitors radars by producing audible sounds. MiG-31 supersonic aircraft is equipped with 2 Solovyev D30 F6 turbofan shaft engines, with a takeoff thrust of 15,500 kilograms per feet each. The dry thrust of the D30 F6 is 9,500 kilograms per feet for each engine. The engine provides a maximum speed of Mach 1.23 at low altitude and increases the aircraft's range. The fuel consumption of the MiG-31 is very high compared to other aircraft, principally due to its multiple roles.